All right, good morning, ladies and gentlemen. This is AP Physics. I'm Mr. Kirsten, and today we are going to be taking a look at chapter number 4, problem number 13. All right, here we go. So this problem deals with an elevator. Um, Elevators, let's draw a free body diagram. Elevators have mass and therefore they have a weight, right? So on our free body diagram, we'll put that. And hopefully elevators have some type of cable system that provides some tension force that stops the elevator from falling to the ground. So if an elevator's at rest, we simply have a tension force up and a weight down, and those are equal and opposite. Now, in this problem, it says that the elevator has a mass of 4,850 kilograms, so we'll want to write that out. And it said it is designed to have a maximum acceleration of 0.068 g, okay, where g is the acceleration due to gravity. Now, the first thing I would do is multiply that by 9.8 and get an acceleration in meters per second per second. And as it turns out to be 0.666 meters per second squared. So as we see here, physics does have a connection to, what is that, the devil or something? Anyway, all right. Okay, so this is all we know. And then the problem simply states what are the maximum and minimum forces that the motor has to exert. So we're assuming that the motor exerts a force on a cable that raises and lowers the elevator. So what's that maximum force the motor's exerting through the tension? What's the minimum force? All right. Okay, well, let's just think about kind of what is going on here. Now, if the tension force is equal to the weight, then the acceleration of this elevator should be 0. All right, that kind of makes sense, right? Now, if we want the elevator to go up, we would want the tension force to be larger than the weight, right? Then A is up. I suppose we should have said kind of in the beginning here, we're using our standard coordinate system here with up being the positive direction. And of course, if the tension force is less than the weight, so the motor exerts less force on this cable through a tension force, then A is down, okay? Down. Let's see, what is a tension force? A tension force is simply a pulling force by a string or a cable or anything like that. A tension force is a pulling force from a string or cable. All right, so let's figure out what some of these things are here. Well, we know weight here. Weight is equal to mg. So let's figure that out. We know the weight of this elevator. So if we plug in 4,850 times 9.8, we find that the elevator has a weight of 47,530 newtons. All right, and just kind of for an approximate thing you can think of, 1 Newton is about a quarter of a pound. Every time I go to McDonald's, I order a Newton burger with cheese, right? Anyway, 1 Newton is about a quarter of a pound. So would it make sense that the elevator is like around 10, 12,000 pounds? Sure, that seems reasonable. Now, by the way here, typically when someone says, hey, how much do you weigh? You don't say negative 47,000 pounds or negative 47,000 newtons. Usually we give weight as a positive number, but it's kind of understood that weight is a force of gravity pulling down. So, in this problem, I've just solved for the weight, but we do realize that this is going to be, a force in the negative direction here, or in the downward direction. Okay, let's put Newton's second law to work here. The acceleration of this elevator is going to be the net force divided by acting on it divided by its mass, right? This is true for all objects, according to Isaac Newton. So let's find the upwards acceleration of this elevator. So here we would have some type of tension max, right? So this is our strong tension force minus the weight divided by the mass, right? Notice here the net force is just the sum of all forces, right? This is a sigma symbol. It means sum of all, right? So there's only two forces, tension with a positive sign because it's up, weight with a negative sign because it's down. And so when the tension force is big and it's larger than the weight, the acceleration will be upwards, and this will be our maximum tension force, or the maximum force the motor's going to have to exert. So from there, we would just do a little bit of algebra here, all right? We would multiply on both sides by m, right? Equals T max minus mg here for the weight, right? So we multiplied by m, and then I'm going to add mg to both sides here and do a little factoring, and I'm going to get this, all right? And if I plug in some numbers here then, I would get 4,850 is the mass times our maximum upward acceleration, 0.666 plus 9.8, right? And we would get a maximum force of 50,760 newtons. Notice here that the upward force is greater than the weight, which is 47,000 newtons, and that kind of makes sense. So that's kind of a check. All right. So let's to solve for the downward acceleration, right? So let's say the acceleration was down, right? We would have, well, I'm going to use this same equation, but then I'm going to put in a T min here minus mg. So we're expecting here this acceleration is going to be negative, all right? And this is going to be a smaller force. So we're hoping when we solve for this tension, we get a number less than 47,000 newtons, all right? Oh, this should be divided by m, right? Same equation as up here, just down and min. Okay, so if we kind of wave our algebra wand at this, we are going to get m times g minus a, and that'll be equal to the T min here. All right, and so basically this ends up being, can you guys still see this? Yeah, 4,850 times 9.8 minus 0.666, and that will be the T min. And if we bring this over here, we get a T min of 44,300 newtons. And notice again that this kind of makes sense because this number is a little bit less than this number. Hence, the tension's less than the weight, so the net force will be downward, and the net force will be downward, and the acceleration will be downward. So that's some information about free body diagrams, Newton's second law, accelerations. Great problem there. So hope you enjoyed that one. Yeah, we got a roll here. So nice work, physicists.